Okay, today's video is going to cover lesson 2.9. This is key features of functions, the first part of a two-part lesson. This should be page number 18 in your notebook, and I just want to say that some of you guys have been doing a great job with your notebook, and if I had to make a metaphor referencing food and your notebook, I would say your notebook is like a T-bone steak. With that said, some of your notebooks are like sloppy joes, meaning your notebook is not very good. You need to start doing a better job. It's never too late to make a reservation at Durant's. If you don't know what I'm talking about, after this video, go ahead and type in Durant's into Google and you'll see what I'm talking about. Make your notebook look like a T-bone steak. Alright, let's go ahead and get into the goal today. Today's goal is to identify the domain and the range, which we already know what they are, or at least what the definitions of those two are. We know what x and y intercepts are, or we should at least, and then the intervals of increase and decrease. This is something that you may or may not know, but you will learn over the course of this 10 to 12 minute video. So, vocabulary heavy lesson. You're not going to like this screen, but it's a necessary evil because once you've got them down, you got them down forever in your notebook. So, let's go ahead and kind of define what domain and range are given a line. We know what they are with coordinate points tables, but when we see a line, the domain is all of the x values that have some point on the line. So, all the x values the line covers. And the range is all the y values that the line covers or crosses. So we've got the x and y intercept. Formal definition is the x value or values depending upon how many times it crosses the x axis, and it's the x value that it crosses the x axis at. So if it crosses at -3, 0, that would be the coordinate point. The x intercept would be -3 because that's the x value. Similar to the y-intercept, except we're talking about the y value the line crosses the y-axis at. And if it crosses multiple times, then you already know it's not a function, because when x is 0, x has two outputs, 2 y's or 3 y's, however many times it crosses, so it wouldn't be a function. And we've got interval, very easy idea, but we'll talk more about what it means. Essentially, it's just all the values between 2 points. And we've got increase and decrease. So you can see what the line looks like. It's going up as you go from left to right. So if we read the line, it's going up. If we read the decrease line, it's going down. The formal definition for an increase function is when the x values, so as you see this line go up to the right, these x values that are to the right are getting bigger. And as these x values get bigger, the y values are also getting bigger. Classic mix-up. The y values are also getting bigger because it's going up higher. Decrease function. So as we go to the right and the x values get larger, the y values are getting smaller because the line is going down. So that's the formal definition of the two. Let's go ahead and get into an example today. We've got 4 of them. And we've got the first example, and the page is white. So why is the page white? Not sure why the page is white. Example 2 is not. Okay, so we've got a white background today, but we're going to go ahead and not discriminate. We can work with white. We just got to get the color right. So you can see here we've got the line. And the first thing that we're going to do is we're going to figure out what the domain is. And we're going to write domain in a new way. We're going to use interval notation for domain. Interval notation, I'll tell you why it's easier in a second. So we've got domain, and we're trying to list all of the x values. So let's go ahead and start with the smallest x value, and we're starting with the smallest x value. We want to go to where x is the smallest, so it looks like right here at what would be a -11, and we've got an arrow. Okay, so this is an important idea in all of math. When you have an arrow, that means that the line has not stopped. It's going to continue going. It just means that the graph isn't big enough to hold the line. Well, when does the arrow stop? Never! When you have an arrow, it goes on forever. This is something I would write down in your notebook. It goes on forever. So this arrow is going to keep going down and to the left, and if it keeps going to the left, what's going to be our smallest x value? Well, if the arrow never stops, then that means it goes all the way to negative infinity. It's an easy idea, but it's very complex at the same time. There's no concrete value that the line stops on. It just keeps going all the way to the negative value. So we just say it goes to negative infinity. Well, what's the largest value that the function contains? It looks like it's between 8 and 10. But there's an arrow, so that means it's going to keep going up and to the right. And if it keeps going to the right, then we know it never stops. So what value is our largest? Positive infinity. There's no concrete number that it's going to stop on. And the reason why we're not using curly brackets is because when you use curly brackets, you've got to list every single value. And if we're listing every single value from negative infinity to positive infinity, we would spend our entire lives writing them. So we're going to use interval notation. So that just means you're listing all the values, the starting and the end point, and all values in between. And we can go ahead and use parentheses because you can't include a number that isn't concrete. If you could include it, you would use brackets. And we'll talk about that in later examples. Throwing a lot of information at you, but nothing that you don't already know intuitively. So, if we talk about range, we kind of already identified that these lines are going to go on forever. So, if you think about range, you're going up and down. So, you're going to start at the bottom. What's the smallest y value? Well, we've got this arrow that keeps going down. And if the arrow keeps going down, that means it's going all the way down to negative infinity. And if the arrow for the largest y value keeps going up, then that means it's going all the way to positive infinity. There's not a concrete value it stops on. So we're just going to say all values from the smallest value to the largest value. Very easy when you see arrows. Pretty much always going to be negative infinity all the way to positive infinity. Now let's go ahead and talk about the intercepts. Well, we've got two intercepts today, and you can see that the x-intercept would be where this line crosses the x, which is right here. And I'm just going to safely assume that the number it's crossing at is exactly between negative 6 and negative 4. I can't say for certain, but I'm going to say probably best just around to negative 5. So we can say that the x-intercept is negative 5. And the y-intercept would be where it crosses the y-axis, which is right here. And I'm going to do the same thing and safely assume that it's halfway between 4 and 6, which would be a positive 5. Last part would be whether it's an increasing function or a decreasing function. And this is a linear function for those that didn't know. So we've got a constant rate of change, meaning that the function is increasing or decreasing at the same rate, whatever that rate is. And it looks like because the line is going up from left to right, that it is an increasing function. So we can just write increasing. And it's going to the questions will ask you all these things, and you'll just type in the domain, the range, your intercepts, and then whether or not it's increasing or decreasing. And there may be multiple increases and decreases. You'll see in later examples what I'm talking about. Don't get ahead of myself. Alright, so we've got now example 2. Very similar to the previous example, except now our background is black and our line is red. And most notably, you can see that there's one arrow right here. Always, 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 always. There's one arrow right here, and there's not an arrow right there. So let's go ahead and talk about the domain first. Again, we're going to use notation to write the domain, so we don't have to list every single value. We can just write all values between this point and this point. And there's not an arrow here, so the line actually stops here, or starts here maybe, depending upon your perspective. And it looks like the x value that it's starting on is right here, which would be 0. So we can say that 0, and I'm going to use a bracket because we know what the value is. Definitely, we use a bracket. When we don't know, like in the previous example, we did not know concretely what the value was, we used a parenthesis. However, in this example, we know it's starting on 0. There's a dot right there that tells us that we are. One day I will get through an entire video without that thing coming up. What is the largest x value that's on the function? So it looks like the function is right here between 4 and 5. However, there's an arrow. We've got an arrow, so that means it's going to go all the way up and to the right. And if it's going all the way to the right, it's going on forever. And if it's going on forever, it's going all the way to positive, because we're on the positive side of x, positive infinity. So that's our domain. And our range, very similar, but now y value. So let's start at the very bottom. And we've got this y value right here. It's a dot, so it's a concrete value. So we can go ahead and put a bracket. And what is that concrete value? Well, this is 1, 2, 3, so it's 2. And what is the largest value? So it's all these y values. We don't want to list them out. We just want to say from here to here, here. Looks like it's got an arrow going all the way up forever. And if it's going up forever on the positive side of y, it's going all the way to positive infinity. And we're going to use a parenthesis because we can't say for certain what that value is that it stops on. Now for the intercept. So we've got our x-intercept. Well, where does it cross the x? Well, I don't see the red line crossing the x anywhere. This is the x right here. The red line is not crossing, so I'm just going to say none. There is not an x-intercept. What about the y? Well, it's on the y, and if it's on the y, we consider that to be crossing or at. And what value is it at? It's at 2, so we can say the y-intercept is 2. Now, whether or not this is an increasing or decreasing function, the line is going up and to the right as the x values get larger, so 3, 5, the y values are getting larger. So we know that this is an increasing function, so we can just write increase. Now for example number 3. 2 more examples. So we've got our domain. Now hopefully, oh my gosh, OMG, can't get through it without getting that thing come up. Always pops up. You'll never see a comment video where that pops up, but you'll definitely see one of my videos with that thing pop up numerous times. So we're talking about domain, and we're going to start with the smallest, and we're going to go ahead and list them. So if we go all the way to the left where the line is, looks like the line, and we've got a dot here. So we've got a dot, so we know concretely what the value is. We just got to deduce it. So we've got zeros here, -1, -2. We got -2. So it starts, or this is the smallest x value included on the line, and we can use a bracket. And let's go all the way to the right, because we've got all these x values are included. All these x values are included, and the smallest x value, we've got another dot, so we can go ahead and use a bracket. The largest x value is, let's go ahead and deduce it, 1, 2, 3, 4. So we can say from -2 all the way to 4 for our x values, there's some point on the line. With range, same thing, but now we're going up and down. Start at the very bottom and list the smallest value first. So we've got this value right here. Looks like it's -4. Since we know it, we're good, and we're going all the way up, all the y values until this y value right here, which would be 5, 6, 7, 8. Good, I can count. So we can say from -4 all the way to 8. We know both of these values. These dots are both closed. Let's go ahead and use brackets. Now for our x-intercept, well, here's our x. Lines crossing right here. What's that x value? 0, 1, 2. And what's our y value? 5's right here, it's crossing right here, it looks like that's 4, so we can say that our y-intercept is 4. And now, increasing or decreasing, so as these x values get bigger, so 2, 3, 4, 5, what's happening to the y values? Well, they look like they're going down, so if their x's are getting larger and the y's are getting smaller, we know that it's a decreasing function. Just write decrease.